too far. Oop, that guy has a gun. And we're back. All jokes aside, though, I think the Area 51 raid is bad for humanity. And let me tell you why I think this. Look, this is fun. It's funny. Sure, some people are doing it just for the memes, that's fine. And I do not think that the Area 51 raid is bad for humanity because we will find something out there that we don't want to find out, or have some technology, or have some alien escape, or whatever meme Elon Musk is putting out on his weird Twitter these days. No, I think the Area 51 raid is bad for humanity because specifically today, the huge contradiction we see in the use of our time and attention. So right now, near Area 51 in Nevada in the United States, there are hundreds, perhaps thousands of people getting close to a government facility for the memes, for the selfies, for music, kind of like a little festival. There will also be speakers there talking about UFOs and ufology. Now, it would be bad enough if we were just talking about the carbon footprint of all of this memery. For thousands of people to go out to Area 51 for no reason when we have no good evidence that aliens exist or that we're keeping them. You can check out my thoughts on that in a previous episode of Because Science Live. That would be bad enough. But the people who are going here and the people that are speaking to the people here are obviously promoting some kind of mistrust of authority, mistrust of science, what we know about the universe, what we know about other forms of life, and where they might be or where they have gone. This is all pretty bad, in my view, and it's wasting time, productivity, money, attention, carbon. Why I think this is a perhaps almost immoral use of our time is because today is also the day that starts the global climate strike initiative, started by a young woman, Greta, who is incredibly impressive to me. But right now, not hundreds, not thousands, but an estimated millions of people in cities all around the world are taking to the streets in Los Angeles, in Germany, everywhere across the planet. They are in the streets asking for real action on climate change. That we are asking that our politicians, that people in power actually do something, and this is spearheaded by children whose futures we're affecting with our actions. Now, I can say that myself and Because Science, we support these strikers. I agree that something needs to be done about climate change. It is the most pressing problem that humanity has right now. And when you contrast this with something like flying to Nevada just for the memes to promote a worldview that is obviously conspiratorial and somewhat anti-science, especially with the kinds of speakers and things that appear there, I think the raid on Area 51 is bad for humanity right now. We should be focusing on what we can change about the biggest problem facing us. It's not secret aliens. It's too much greenhouse gas in the atmosphere, and we are the culprits. So, in my view, we should not be looking to the stars for answers and for change. We need to be looking a lot closer to the ground at ourselves, and we need to actually make a difference. This is going to do nothing. This is going to be a selfie that you're going to put on your Instagram that you're going to forget after it gets 50 likes in a week. Climate change is going to affect your kids. Hello and welcome to another edition of Because Science Live. Woo! And we always start out real low energy like that. We're going to get more fun. The live edition of Because Science on this channel where I answer all of your comments, questions, and corrections to the best of my ability off the top of my head. Yes, we are doing this live. Look, I'm not an expert. I probably know more than a ufologist does, but I'm not. Ufology slam. I am not an expert, I'm not a working scientist, but I know a little bit about a lot of sciencey and pop culture-y things. So if you have a question for me, please put it in the chat wherever you are watching this, especially on YouTube, and Voice of the Void Nate can get to that question if it is a good, nerdy, thought-out question, and you're not spamming, because then I'll never answer your question. Never. What's up, Nate?
What's up, Kyle? How's it going?
I don't know, just chastising nerds for being way too memey.
As
I want to do.
As you run in Naruto style.
That was unrelated.
From Amal Ruwala.
Hello.
Which is your favorite paradox and why?
Favorite paradox. So paradoxes isn't just two doctors. It's a situation that is logically I feel you shaking your head at me somewhere. It is a logical inconsistency. So two things when put together that don't make logical sense. So one of my favorite examples of a paradox is something we've talked about, or we will be talking about in an upcoming episode of Because Science, the grandfather paradox with time travel. So if you could travel back in time, you might be able to go back in time and, say, eliminate your grandfather, which means you would never be born to go into the future and then into your own past to eliminate your... It's a paradox. This causally cannot happen. But one that you may not have heard about or may not remember if it's been a long time since you've taken math class is something called Zenos Paradox. It has nothing to do with xenomorphs, but Zenos Paradox. And it's been a while since I thought about this one myself, so if I get it wrong, you can correct me. But Zenos Paradox is, imagine that you are some distance away from a wall. And for whatever reason, let's say you're under the influence of some spell, for whatever reason, you can only move towards the wall in increments of half. By which I mean, you can move your first movement towards the wall, you go halfway towards the wall. In your second movement towards the wall, you cut the distance in half, and then you cut that distance in half, and then that distance in half, and then that, and then that, and that, and that, and that, and that, and that, and that. Now, mathematically, the paradox is if you're always cutting the distance in half, you will never touch the wall. And yet, if we think about movement practically, we know if we actually did this, our faces would hit the wall. But mathematically, it doesn't. So there is some kind of paradox here between the way that we think about this situation mathematically and the way that we actually move through space and through time and how we talk about these things and what words that we use. But Zenos Paradox is a fun one because it's not immediately apparent. It's like, well, yes, you would never touch the wall, but how do we touch the wall? It's kind of a fun one. So I'd say Zenos Paradox, and if you look that up on something like Wikipedia, that will probably lead you down a rabbit hole in halfway chunks that will lead you to other famous paradoxes, and I suggest looking them up. They're all more interesting than rating. Unless you're on classic WoW. Isn't that great that they up-res that? Taking a lot of shots today. What's next?
From Matterbeam,
OGMB.
we've crossed the point of no return with CO2 emissions, and we're not slowing down. What's your solution for dealing with excess CO2 after it has reached catastrophic levels, not before?
Okay, so Matterbeam, you do realize that you're asking me to solve climate change, right? I do not know. So I will preface this by saying that I don't know whether or not we are past the point of no return, that we've added too much carbon to the atmosphere. I think the most recent papers that we have is that we're close. Like, if we don't want to turn into some kind of runaway greenhouse effect planet, we need to radically cut down our carbon emissions, ideally to zero or net zero. Like now, within the next 5 to 10 years, 5 to 10 to 25 years. Very soon, we need to stop. What I'll say is, what's additionally scary about climate change is that the atmosphere, the world's air, is a gigantic system. I mean, right? It's all of the world's air. And so it takes a long time to change that system, which is why the change happens gradually over time and it's harder to see, and that's why people are like, well, I don't see it. Well, you'll see it over time. Anyway, so climate change is like steering a cruise ship, giant cruise ship. You can turn the wheel, but it might take a while for the ship to actually change course. And I bring that up because the effects that we're seeing right now globally with the increase in temperature and melting ice and raising sea levels and this kind of thing, local temperatures spiking. Australia had to add a new color to their heat maps of the country that look like black, look like Mordor in there. That's great. Why I bring that up is because we're only seeing the effects from like 50 years ago. It takes a long time. We're seeing the effects from decades ago now. And since decades ago, we've ramped up how much carbon we put in the atmosphere from just livestock that we're raising, from the billions of cars that we have on the planet. I think it's like 1.2 billion cars or whatever. So the effects that we're producing on the planet right now by adding carbon will be seen for decades and decades to come. The worst of it, we may not have even been through yet. If we think it's bad now, it's only going to get worse. And that's what's scary. Even if we pump the brakes right now, magically, we hit a button and we went carbon neutral this instant, we'd experience the effects of climate change for decades. And it wouldn't stop reversing itself. So that's very scary. All that being said, if we pass the point of no return or we're getting close to it, how do you deal with the excess of carbon in the atmosphere? I don't know. There's a lot of potential solutions or solutions that are talked about, whether that be you could build facilities that employ carbon sequestration, that uses chemical processes to pull carbon dioxide out of the atmosphere and make it solid, like put it into a solid form and then bury it. Put the carbon back in the earth where we found it. You could do that. Obviously, moving towards greener energies will cut down on carbon emissions. But to take carbon out of the atmosphere, something like sequestration would have to be the technology that you're looking at, physically pulling carbon out of the air. Other than that, we just have to stop and then live with the effects afterwards. So, Matterbeam, I do not know what the solution is. I wish that someone did. I wish we had something more actionable, but I guess that's what millions of people are striking right now, this second, about. What's next?
From Florian.
Florian, what up?
What can we scientifically do with genetic engineering?
Genetic engineering has taken leaps and bounds in the last couple of decades. I mean, some of the hottest technology, some of the hottest fields of research in bioscience, it's a term, right now is, things like CRISPR, which you've probably heard about. CRISPR stands for clustered, regularly interspaced, short palindromic repeats. And from that, you get the acronym CRISPR. This technology is basically like a genetic scissors, and I'm mentioning it because it's the most famous example of genetic engineering right now. It's like a genetic scissors, and what it can do is you can program it to go in and to cut any sequence of DNA that it recognizes that is like a palindromic repeat, a series of letters. You can go in, it can find those series of letters, those bases in your DNA, cut it out, and you can, in theory, put something else in. With that kind of genetic engineering, the kind of stuff that we could do is crazy. Not like make like alien, nope. Not like make like plant-human hybrids or something like Guyver or something style. But, I have to talk about this carefully. You could, go into the womb as a baby is developing, for example, at the very, very early stages. You could pick eye color, you could pick different traits, you could do a lot of things. You could clone people, not with this specifically, but we can clone humans. I mean, you could change humans a lot. That being said, we don't do these kinds of things, even though we can, at least right now, because of ethics. Because it's ethically murky to start changing living things and the genetic makeup of living things. Scientists will say we shouldn't be altering people in this way. It's against some kind of natural order. Others will say, why not? I don't have a real opinion at the moment. But the stuff that we can do with genetic engineering is significant enough that we're starting to attack genetic diseases and outright cure them. So if you can outright cure diseases that would be incurable otherwise, you can probably guess on the other levels of stuff that we can do to the human body. But again, we don't do most of that stuff because ethics, which could be its own show. But being a normal, good person, I wouldn't do that show.
Not a supervillain.
No. What?
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 From Jen Kenobi.
Jen Kenobi?
Yeah.
Like old Jen Kenobi?
Yeah.
Wow.
The very same.
Haven't heard that name in a long time.
If you could spend an hour with any scientist of the past or present, who would you choose?
If I could spend an hour talking to... I think I would speak with Richard Fineman. If you've watched any of Richard Feynman's lectures, read any of his material, his books, if you've watched... I forget what the segment is actually called, but it's about an hour long, and you can search it on YouTube. It's Richard Feynman talking just in a chair, just in like an office chair, just to an interviewer about like how magnetism works and how you can get energy out of burning stuff. And he talks about it in such an interesting, simplistic way. Richard Feynman was known in the physics community, as far as I understand it, for having a lot of little tricks and a lot of little wonderful little insights into how to make things work, how to make certain mathematics work, and how to explain certain things. So I would love to converse with Richard Feynman for an hour, pick his brain, and then also just kind of learn from him and how he communicates as well as he did. He would have been 100, I think, a year or two ago. So yeah, I think I'd go with Richard Feynman. Then I'd be a fine man.
Oh boy. From Hooky Meats.
Don't need the additional commentary on the
what would be more likely? Terraforming a planet in our own solar system or in another?
Well, terraforming, just base level, is super, super hard. Bringing this back to the climate strikes today, if terraforming was easy, we'd probably be doing it in a substantial way right now to reverse climate change. That we're not speaks to political inactivity and economic factors, of course. But the fact that we can't even reverse what we're doing to our own planet speaks to how difficult terraforming an entire world in a short amount of time would have to be. And if you're going to terraform anything, I would have to say this one is fairly dependent just on the fuel. It's going to be much easier to get stuff, people, technology to a place within our own solar system than it would be to another world. If you think about how far away the next world could possibly be, go to the next star system. It is I believe it's 4.3 light years away. So even if you were to travel at the speed of light in a spacecraft, which is impossible, it would still take 4 years to get there. Now think about the round trips that you would have to take. These are immense distances. So if you wanted to terraform anything, we need to start here. Well, I mean, my here is different from your here, but you need to start on Earth and then expand outwards. Solar system first, then other star systems after that. Everything in space is just too far away to take gigantic risks like that with what would have to be gigantic quantities of material and people and things. What's next?
From Simon K.
Prove it.
How strong would you have to be to rip out someone's heart?
What's that? You want to rip someone's heart out? Kali Ma style?
Kali Ma.
Shakti Day. You betrayed Shiva. It's a good movie. Doesn't age amazingly, but it's fun. So how strong would you have to be to rip someone's heart out? Well, without finding some really weird papers and doing some weird estimations, I will not be able to tell you this answer off the top of my head. I will say that when, say, an autopsy is performed on a person, they have to use a very technically termed instrument called a bone saw, who is ready. God. You have to use a bone saw or something like a rotary saw to cut through the ribs and the chest cavity to get into the internal organs, into where the heart would be in your body. If you got to use something like this just to get through this material, it gives you an idea, if I don't have real numbers for you, it gives you an idea of how hard it would be to force your way through and to get someone's heart and to pull it out. Not to mention that it's going to be wet and slippery and gross, and it's going to be attached to a bunch of valves and veins, and it's going to be moving, so it's going to be hard to hold on to. How strong you have to be? I don't know. Pretty strong. Like your hand was better than a buzzsaw. Like Superman punching through the Joker. Although he punched him like this, which was always weird to me. I guess that would be more pressure if he was fingered. What?
From Jay the Bard.
Sing me a song.
How close would a small black hole have to get to Earth or even our solar system for us to start noticing its effects?
Yeah, this one's difficult because it really, really depends on the size of the black hole. So how close would a small one have to get? I don't know. Like I said, if it was like this size, this would be like the mass of more than the mass of our moon, like this close. So obviously the gravitational effects of something like this is very, very substantial. However, I will say that gravity acts such that the further you are away from it, it decreases very, very quickly. So if you move twice as far away, the force on you from that gravitational influence goes down by not 2 times, but 4 times. So it decreases very quickly. It's kind of like magnetism. So you could have 2 magnets that are very, very strong when they're the attraction is very strong when they're touching each other. But you know, even with strong magnets, you can pull them apart just like an inch or a few centimeters, and you almost feel no attraction at all. Gravity is similar. So it stands to reason that even if you had something like the mass of the moon in a small space like this with a huge gravitational influence, you might be able to just, move maybe this far away and you wouldn't necessarily feel any influence. But because this would be in the atmosphere, of course, atmospheric gases would start cycling down into the black hole, creating a small accretion disk around it, generating a lot of heat. But that heat would, but this accretion disk would be self-limiting because of the Eddington limit. If you want to know what I'm talking about, you can go back to our black hole Jupiter episode. So all that being said, I don't know the exact numbers because you would need exact numbers on the size of this black hole. But I think a black hole, a small one, you could be kind of far. You wouldn't have to be a planet's worth away from it for it not to be as dangerous as you think. I'll say that. What's next?
From Retro Gamer Studios.
Word.
What would be the best supervillain pet animal? Robotic wasps, sharks with lasers, flying monkeys?
Depends on where you are. If you have a undersea base, I would go with souped up intelligent orcas. Orcas, or killer whales, are terrifyingly smart, and they're strong, and they eat great whites. They're the scariest thing in the sea, to me. You see, so orcas, hyper intelligent orcas. If you're in the sea, if you're on land, I'm gonna go with. I don't know why I thought of rhinos in riot gear, but let's go with that one. Could you imagine trying to get through a blockade of rhinos in riot gear with little face shields on their derpy little faces? That'd be funny. If you were in the air, of course you must go with the weaponized locust. Not only do these locusts, not only do they descend on an area by the billions, eating up every single available crop in the area, they are also wired with small M80s so that you could have billions of tiny explosions converging on any one point at a moment's notice. Those would be mine.
Nice.
Thanks.
From Dustin Jacobs. Nice.
I needed that approval.
From Dustin Jacobs, who would you like for the Magic the Gathering 2019 Commanders and the new expansion coming out?
Sure. Hey, so non-science question, that's fine. I'm a huge Magic the Gathering fan. I play it every week as much as I can. I play mostly Commander. Out of the 2019 Commanders, the one that excites me the most, I tend to build towards less casual, more powerful stuff. It's just the way I like to play. So Crick, son of Yawgmoth, is straight up broken from C19. And I have a friend who has a deck that I think won on turn 2 last time he played Crick. So Crick is very compelling just because he's so powerful. From Throne of Eldraine, the next set, I like the King, the 5-color King, has a lot of cool abilities that you could use. Also, I like the Esper Fairy Tribal that you could do with artifacts and enchantments. I think there's a lot of good legendary creatures in there, and I look forward to slotting a lot of those cards into my EDH decks. I'm already looking at it.
From Fountain Phil.
He's got a lot of wisdom.
Could you turn a black hole back into a star?
What? I don't know. No. What? No. Who? No. I don't know. I have no idea. A black hole, I think it's more instructive to think of it as less of a thing, like a sphere, like less of a sphere and more of like a rip in space-time, like a hole in space-time, a gravitational disturbance that is so great that light cannot even escape from its gravity well. It's less of a thing. And so once this non-thing has formed, it would be hard if you kept throwing mass into it, say to try to turn it into a star like we tried to turn Jupiter into a star. Keep throwing mass at the black hole's only going to get bigger. So that's not going to solve your problem. And if you try to make the black hole smaller, it's only going to evaporate away and release a lot of Hawking radiation as it does so, and then eventually it's just going to pop out of existence. So I don't think there's a way to make a black hole into a sun if it was once, a very large star, and then it collapsed down into a neutron star, supernova, back into a black hole. I don't think there's a way to do that, but like we talked about in the Jupiter black hole episode, you could put enough material around a black hole such that when material was falling into it, it would give off enough energy in this accretion disk as all this material heated itself up and it bounced against each other and became really hot through all this friction. Enough of that heat can be produced that it can mimic a star. In fact, it can get so bright it'd be much more luminous than the sun. It could be the brightest thing in the solar system or in the galaxy easily. So throw enough material around a black hole in the right way, and you can make it as though it is a star. With gravitational influence and a crazy luminosity, you can make it like a star. But turning it back into a star, I don't know if that's really a process you can do, because once space-time is pierced, it's hard to plug it back up.
All right, 2 last questions.
Oh, okay.
Really easy, really fast.
Okay, we'll see.
From Nightmare Masochist, how do you think you would react if they did find aliens in Area 51?
That'd be amazing. I'm not down on aliens. I'm not saying they can't exist. Mathematically, they probably exist somewhere in the universe. We just do not have any good evidence that they've ever been here or that we're hiding them. If we did find aliens at Area 51, which we won't, I'll bet you on that, which we won't, it would be the most important and amazing revelation in the history of humanity, and I would be the most excited. Wow, look at all these things that we can learn now. It's kind of bad that we are hiding this from everybody, but I kind of understand it because of the panic it would produce. But finding aliens, finding extraterrestrial life would be the most important thing that we've ever done, and the most interesting. I'd be super excited.
All right, last one.
I wouldn't be like, nah, put them back.
From Professor Peril.
Ooh!
As one supervillain to another, what would your preferred doomsday weapon be?
Is that your supervillain accent?
That's how Professor Pearl sounds like to me.
Professor Peril.
Yeah.
I like that. My preferred super weapon would be, I think I mentioned this before, but I think my preferred super weapon would be gray goo, and I'd carry it in a tiny vial. And gray goo is a colloquialism for self-replicating nanomachines. So nanomachines that are on the billionth of a meter scale that can go basically approach any material and take it apart, like atomically, more or less, or piece by piece molecularly, and they can use that material to make more nanomachines. So it's like a growing swarm of goo, kind of like nanoscale locusts that make more and more and more of themselves. So I would take a vial of, I was hoping we'd come to some agreement, but unfortunately, you're goo! And then I'd break a vial of nanomachines on their chest, and it would slowly envelop them until they're nothing but nanomachines, and it would go back into a larger vial, and I'd be like, I really wish I didn't have to do that. But now, I had to goo that. And on that note, that's all the time we have for this edition of Because Science Live. Thank you so much for joining me this week. Next week, of course, we have more of everything that you've come to enjoy from this channel, all this great goo talk. We have new footnotes, new main episode. It's a weird one, totally not supervillainy, I promise. And we have a new live. Again, we are obviously working today, but because science, standing with the climate strike, don't go to Area 51, waste resources and time and stuff like that. Got to take a stand sometimes. If not for something, take a stand for the planet. Have a wonderful rest of your weekend, and be nice to each other, because this and this planet is all we got.